Let's solve this calculus problem step by step. We need to prove that when we differentiate y equals x to the m times natural log of x with respect to x, we get x, y1 equals m, y plus x to the m. Let's start by differentiating y with respect to x. Since this is a product of two functions, x to the m and natural log of x, we'll need to use the product rule. Now, let's find each derivative separately. The derivative of x to the m is mx to the m minus 1, and the derivative of natural log of x is 1 over x. Let's substitute these derivatives back into our equation. We get y1 equals mx to the m minus 1 times natural log of x, plus x to the m times 1 over x. Let's simplify the second term. X to the m divided by x is equal to x to the m minus 1. So our equation becomes y1 equals mx to the m minus 1 times natural log of x plus x to the m minus 1. Now, let's multiply both sides by x. When we multiply x times y1, on the right side we get mx to the m times natural log of x plus x to the m. Look at the first term on the right side. Remember that y equals x to the m times natural log of x. Therefore, mx to the m times natural log of x is equal to my. And there we have it. We've proven that when we differentiate y equals x to the m times natural log of x with respect to x, we get x, y1 equals m, y plus x to the m. This is a beautiful result that shows how differentiation of logarithmic functions with powers can lead to elegant relationships between the function, its derivative, and its terms.